As testers and test managers and developers, we are faced with a challenge that we have to test more and more software functionality in less and less time. We have to test more and more functionality because successful software grows. We typically keep on adding new features, and very infrequently are we allowed to remove existing functionality. But since we keep adding features, we have to provide more and more tests to make sure that the existing functionality keeps working. Ironically, however, we don't get more time to perform more testing, but less, because release cycles are shortening. And typically, most of the customers we work together with tell us that they get less and less time to perform more and more testing. To meet this challenge, we are convinced that we must develop as a testing discipline to be able to better focus our testing efforts on those areas of the software system that are most likely to contain new bugs. And test gap analysis is one such analysis that helps you with that. And today in the workshop, we want to explain the research foundation behind test gap analysis, share experiences from practical use cases we have with our customers, and also do a demo so that you can see how it feels in our tool TeamScale. However, before I start, please ask questions immediately. Don't wait with the questions until the end of the talk, but feel free to interrupt us with questions at any point, either via the microphone or via chat. And it's also fine if it's not a well-articulated question, but just your own experiences or skepticism or doubt. The more interactive we get this workshop, the more information you can take out of that. The situation that you have more and more functionality to test in less and less time is something that we see across our different customers. And in case this is a situation you are faced with as well, you are in good company. The logos on this slide are of all the people that registered until last week to this workshop today. And the key point we want to make here is that this challenge that more and more functionality needs to be tested in less and less time is not limited to a single programming language or organization type or development process, but we see that across the board and also across the hundreds of customers that we have that use our analyses. Last slide on the background, so that because I don't know how well you know us as a company, CQSE is a spin-off from the Technical University of Munich. I and the other founders met 15 years ago in a research group when we did our PhDs here at the University of Munich, and we founded the company 12 years ago. We are now 49 employees, 46 of which are computer scientists, 20 of which have a PhD in software engineering or software analysis. So we are very focused on software quality analysis. And we are in 2 time zones, in the North American time zone and in the German time zone. We have different offices across Germany. I am sending from Munich, but also prior to COVID, we had a lot of remote employees. So independent of where you are, either in the European time zone or in the North American time zone, it's very likely that one of our colleagues will be in the same time zone or even close to you. So enough of the backstory. We want to do this workshop in 3 parts. I will do the motivation and the research studies we did that sparked test gap analysis. Then Fabian will show practical use cases, and Jakob will do a demo of test gap analysis in TeamScale. To wrap up, I will present a cost-benefit analysis we did with one of our customers to answer the question, what is this actually good for? And at the end of the workshop, we have time to do breakout rooms. Fabian, Jakob, and I will go into different rooms. So if you have some questions which you feel are not of general interest, but you would like to discuss one-on-one, you have the opportunity for that at the end in the breakout room. So how can we get the most out of our test resources? And by the most, I mean, how can we find the most bugs in the given time or effort we have available for our testing? And to answer that, luckily, there's a big body of research knowledge. There's a whole research domain with several decades of research called defect prediction. And the goal of defect prediction research is to identify characteristics of software that allow us to predict where or which bugs will occur next. And one of the very fundamental discoveries of defect prediction research is that for long-lived software systems, most production defects occur in those areas that changed since the last release. That's, for a practitioner, not very surprising, because that it matches our gut feeling that the functionality that wasn't touched in years is probably either working or nobody cares, but the areas we changed or added are most prone to have bugs. So most of the people we work with do that already. They try to focus a substantial part of their testing onto those areas where most changes took place since the last release. So what surprised us when we started in this area from a research perspective was not that the research shows that many bugs are in those areas that changed, but what surprised us is how hard it actually is to make sure that you really test those areas. And I want to give you two reasons why this is hard. And on these screens, you see the different issue tracking systems we used in our own development history. We started out with whiteboards. Very early on, we used Bugzilla. And some years ago, we migrated to Redmine. And now for a lot of years, we're using Jira. So every single change we do to our software must be documented via ticketing in Jira. And most of our customers use something similar, independent of how the systems are called and which software is used. You always have a unit of work described in such a system. And as a tester or test manager, whenever I plan my testing activities, I try to make sure that I test those areas that were mentioned here. But there's two reasons why this is very hard to do thoroughly when we do black box tests. The first one is that depending on the type of change that's being performed, it's very hard to make sure when we do a black box test or a UI test or an API test, it's very hard to make sure that we actually hit the changed code areas with our test. And why is that? Because there are some types of changes that don't reveal which functionality was changed. And I have a statistic here from our own development where we categorized 2,000 of the tickets from our issue tracker. And we categorized them into the 4 categories, which are typically used in the literature. Adaptive change means a third-party component we use changed. And now we need to change our own software so that it still compiles or still works. Preventive means there's some code that's hard to understand or hard to extend, and the developers perform a refactoring without changing the functionality, the behavior, or at least without trying to change the behavior, so that at the future point, it's easier to make further changes. And corrective means bug fix, perfective means new functionality. Now, if we design a test case, corrective and perfective changes are rather straightforward. For corrective change, I want to make sure that the bug is gone. And for a perfective change for a new feature, what you always do, you think about the different test cases that might be important to make sure this works. But for adaptive and preventive changes, I don't really, if I read that we adapted to a new version of the Oracle database driver, or to Log4j, for example, one of the third-party components that supposedly half the internet is using, I don't know which UI tests I should do, or which API tests I should do to touch those changes. And from our statistics, roughly 15% of the changes we perform are this type. So, and according to the literature and what we see in other systems, this is probably transferable to other systems as well. So for these 15%, it's very hard to make sure that we hit the changes. There's a second reason, which is much more trivial, but has probably a bigger impact. We've worked with some customers where a lot of changes that happened to the code were not documented. And why is that? Typically, those were projects that had a lot of pressure and a lot of management attention. And one of the projects I worked with myself, and which I still vividly remember, had 5 priorities for tickets. And everybody knew that only the highest 2 had any chance of being implemented at all. But a lot of the salespeople knew developers personally. And now if a salesperson had promised a feature to his or her customer, and they knew it wasn't in the 2 highest priorities, they knew there was no sense in entering the feature in the system here anyhow, because it had no chance of ever being implemented. So what they did is they went to the developers and convinced them to implement that feature and put their own relationship with the developer on the line. And the developer didn't enter that in the system as well, because otherwise he or she would have to justify themselves why they implemented that feature that didn't have the high enough priority. And in that system, roughly 1/3 of the changes that were performed were not present in their issue tracking system. So even if you very thoroughly as a tester or test manager test everything that's documented here, you can't be sure that you really hit all the changes to the code base. And during our research, we were interested how severe the consequences of this are. And in 2012, 10 years ago, we did a study with our customer Munich Re, back then our research partner. And what we did with them was quantify the impact of untested changes in production. And for that, we completely analyzed 2 entire releases. And we categorized the code into changed and unchanged code and tested and untested code. And for that, we profiled the entire testing efforts, automated tests and manual tests, to know for everything that was tested, which test or that it was tested or not. And then for months after each release, for every single bug that was reported by its users, we together sat down with the developers and traced the bug to the method it occurred in. And we did that for a year, and in the year there were 2 releases. And in both releases, 15% of the existing code base was changed or added. And in the first release, half of the changes slipped through testing untested into production. In the second release, 60%. And when we traced the bugs that were found, we found that the probability of production bugs was 5 times higher for the untested changes. So this part down here wasn't really surprising. We didn't know how much more likely bugs were in untested changes, but 5 seemed like a plausible number. What really surprised us was that in both cases, half of the changes that were performed by the development team were not ever executed during testing. And that really surprised us, because Munich Re back then already had a very structured test process. So it was not because they didn't want to or didn't have the discipline, but simply because it's a very complex problem. And our experience is that you can't get this correct if you don't have dedicated tool support. And the basic idea of test gap analysis is to show you the untested changes before you ship the code into production, so that you can make a conscious choice whether you want to test that or not. And how do we do that? By combining 2 different technical analyses. We have a static analysis that compares source code revisions, the release version against the current version, to see where are changes. Second, we have a dynamic analysis called coverage profiling that captures the test efforts, both of automated and manual tests, to see which code does actually get executed during testing. And then we combine that to see where are untested changes. And to make that more tangible, I want to introduce a visualization called tree maps, so that I can show you which data we get and how the results of such analysis feel before we get into more details later on. This is a tree map. The basic idea of a tree map is that we use rectangles to visualize components of the software. Each white rectangle here represents a component in the business information system, again from Munich Re, because they allowed us to share this here. And the bigger the rectangle surface area here, the bigger the corresponding component in lines of code. And now I drill into this. Every black rectangle now is a file. And if I go further, every small rectangle now is a method or function. And it still holds, the bigger the surface area of the rectangle, the larger the corresponding method or function in lines of code. Now I can use this map to show test and change information, test coverage, and test gaps. This tree map shows the code changes. This system back then, 10 years ago or 15 years ago, had 2 releases per year. Now they're releasing much more frequently, but back then, 30 developers had been working for 6 months to produce these changes. And the colors mean the following. Gray means unchanged. The same code runs like this in production. Orange and red is changed and new code. So we see that in this area, not much changed, and here's a lot of modified and new code. Now I want to use the exact same visualization for test coverage. And here we have this picture. Now gray means not executed in test, and green means executed in test. And here we have aggregated the test coverage information from different test runs and also from automated and manual tests. So green means executed in some tests we did, and gray means not executed at all during testing. Now the interesting bit is how this looks if we combine the information. And on this tree map, you see the test gaps, and the colors mean the following. Gray means unchanged, independent of whether it was executed during testing or not, because we know this is the code that has a low likelihood of bugs because we tested it earlier on and it's been running like this since the last release. The colorful stuff is the new and modified code, and only if it's green was it ever executed during testing. And what we're interested to see is, are there any big orange and red areas? Because that means there's a lot of modified and new code, and we know that we didn't execute any of these. Yes, I just see there's a question in the chat. Does these tests also include unit tests? Yes. The short answer is yes, as Fabian wrote. The long answer is it depends a bit on what you're interested in. As we will show later on in the demo, you can upload several coverage sources, unit tests, integration tests, manual tests separately, and then look at these tree maps from that test perspective you're currently interested in. But for this example I had here, all the testing activities that were performed for that system were included in the coverage data here. Thanks a lot for the question. Please ask more questions or comments. Now, what about manual tests? How are check here? Do you mean how we capture the coverage of manual tests? Fabian will answer that a bit later on. Thanks for the feedback. The short answer is, and Fabian can give a bit more details maybe later, or we should see in the demo. The short answer is the coverage profiler, the tool that captures the code coverage. The coverage profiler doesn't care whether it's an automated test or a manual test. And as long as it's configured properly and present on the machines on which manual tests are performed, it can simply capture test coverage for manual tests as well. Actually, most of our customers that use test gap analysis do at least a part of their testing efforts with manual tests. And actually, we see that for most long-lived software systems, there's still a significant part of manual testing, even though at conferences, you mostly hear talks about automated tests, and at coffee breaks, you tend to speak at those conferences more about automated tests. Manual tests still play a prominent role. If you feel free to share that, I would be interested to see in chat if automated tests are interesting for you or not, or if you have a different experience here. So I would be it would be great if you could write in chat whether yes, you're still interested in automated tests, or no, in manual tests, sorry, or no, if manual tests don't play an important role in your testing efforts. But back to the slide here. How can we interpret that now? Green means it was executed during test. We don't know how thoroughly it really was tested, because we don't know which assertions were run by automated tests, or for manual tests, if the test actually focused on that code, or if that was code on the way to or from the actual test point. However, for all the orange and red areas, our interpretation is as trivial as true. Because we haven't run a single test, we can't have found any bugs that are in there. So what we want to do here with test gap analysis is reveal, are there any bigger areas of new and untested code, new or changed untested code, to allow you a conscious decision about whether you still want to test that or not. And how do we integrate that into the test process? In a way so that the analysis is running fully automated. So even though it's important for all those that do manual tests, that the coverage for them is also captured, it's equally important that it doesn't affect the way you do your manual tests. And the capture of coverage happens entirely in the background, so that it's not more effort or more clicks or anything for the manual testers. And then frequently we collect the information. Typically, at least once a night, we produce a new tree map, so that you can then in the morning look at the tree maps to see, do they match your expectations? Or if there's test gaps you don't want to have, maybe you want to decide to do further test cases. One important disclaimer. Even if everything is green, that wouldn't mean that there can't be any bugs left. I want to repeat that, but as we all know, testing can never prove the absence of any bugs left. We can only show that we found bugs. And this obviously still holds true for test gap analysis. And further, we don't think it's a goal in itself to get everything green here, because software trade-off decisions require context. In this case, what the functionality behind the code actually is. And sometimes it might not be a problem if something doesn't work. Maybe it's functionality we only need for the balance sheet in December, and we know we're going to do 5 more releases back until then. And maybe it's not important if it works now. Or it's some internal functionality which is easier to fix than to test. I don't know. But it could be that it's not a problem. So the goal of test gap analysis is to allow you a conscious choice. I'm just reading chat. Thanks a lot for participating here in the ad hoc query. I see that for a lot of you, they are still relevant. Thanks for that. So this wraps up the first high-level glance at test gap analysis. Why we do this and what the basic building parts are. Before Fabian takes over with the practical examples, now is a good time for questions for the general concepts and what I showed so far. Do you have any questions or comments about the part for the part I presented until now?
Yes, there is one question.
Okay, thank you. I would like to know how you get the result of unchanged lines of code or changed lines of code which are not tested via percentage. And my second question is if there is a possibility to, for example, mark some regions which are, for example, red here in your sheet, but you don't want to fix it now and invest in creating tests, but you want to invest in creating tests, not the next, but the further next release, so that it is just in your mind and you can then address testers by writing these tests, for example.
Thanks a lot for the questions. Let me maybe answer the second question first. As we will later on see in the demo, the tool is obviously much more interactive than the PowerPoint slides I have now. And right now we look at the entire system. But in the tool you can configure dashboards with arbitrary subsets of the system. And you have filter opportunities where you can exclude all those areas you're not currently interested in. So if you find test gaps which don't matter now, you can exclude them for now, and you can remove the filter later. I don't think we have a functionality that reminds you to remove that filter. I think you would have to use your to-do list or your issue tracking system or whatever you use to plan the stuff for the next release to then target that. But I think most of that should be possible. Could you ask the first question again? Sorry.
Yeah, my first question was, how do you get the percentage of the different colored fields?
In the background, we have a very detailed program model. We have scanners and parsers and connect to the version control system. And for the reference version and the current version, we know for every single method how long it is in lines of code and source lines of code, what changed and so on. And then we can count the different lines. Does that answer the question, or was your question meant in a different direction?
It nearly answers my question, but it answers my question, but I want to enhance.
Yes, please.
And the enhancement would be, I don't want to know how many lines of codes were tested, but I want to have a bigger overview, for example, to tell me how many % of the modules are not tested. Could I explain it?
Yeah, let me rephrase. I think you want it at a different level of abstraction. You want it more aggregated, correct?
Yes.
We have trends where you see which percentage of the code is in which area, where you don't have to look at the premaps. And we also have an architecture description mechanism in TeamScale through which you can model the components you're interested in and then focus on these or use the component hierarchy as an aggregation mechanism to look at that. So I think that should be possible. And if not, you can always access all that data via an API and then do the aggregation yourself. But typically our customers have dashboards where they see trend charts and only tree maps for those areas they are most interested in right now. And, does that answer the question?
Yes, one enhancement, please.
Yes.
And so best practice, what does your customer, what is the interest of your customer? Is it modules or is it, I don't think it's files, but it's something more abstract?
Yes, I think that's a very good segue into the next part of the presentation, because that's one of the things Fabian will talk about.
Okay, thank you.
And if not, please raise the question later on again.
Okay, thank you.
Thank you.
So before you take over, Fabian, there's actually one more question in the chat, so I would just insert that. So the question is, apart from these 4 categories which you've mentioned, so the 4 different colors on the tree map, could we also know which part of unchanged code were included during testing?
Yes, very good question. Thanks a lot. Yes, we have all that data. And for example, on this tree map, you see all the test coverage information. And that data is also there in TeamScale. Thanks for the question. Fabian, I don't see any further questions in chat. Do you want to take over?
Can do. Please let me know when the slides are coming up.
We see them.
Awesome, thanks. So I'm this Fabian you've heard so much about. I lead the team here at CQSE that helps all of our new customers who are trying out one of our analyses for the first time. So for example, test gap analysis. So I see a lot of people using it in practice, and I have a bunch of practical examples, which are the most common use cases we see at our customers for test gap analysis. And I'll walk you through those, but before we do that, I want to go a bit into more depth with the technical aspects, so you fully understand how does this work on a technical level. I think that's important to understand the examples. We've already touched on a few points before. So the first thing is what is the kind of data that we need for the analysis to work, and where do we get it from? One aspect is obviously what Elmar already showed. What did change in the software system between two releases or within a sprint or whatever time frame you're interested in? And this is very conveniently already stored in your version control system, all of the information that we need for that. And this is where TeamScale gets it from. And we support a wide range of version control systems here. You see an excerpt here. And even if your version control system that you're using is not on our website, there's some ways to still get the data out of there and get it into TeamScale. So in those cases, just contact us and we'll help you out. But generally, for the most common version control systems like Git, SVN, and TFS, you just create an account in TeamScale. TeamScale connects to the version control system by itself and pulls in all the data that it needs. This is very easy. The other side is, of course, the dynamic analysis, the test coverage data that we need, which we get from the test systems where you actually perform the tests. And here I'll go into a few different aspects. One thing we already talked about is how does this profiling actually work? Emma already told you it doesn't really matter what kind of test you're running. These tools that we use always record the same kind of information, which is basically which lines of code of your software system that is running somewhere is being executed while you do the tests. And the reason this doesn't matter for the profiler tool, which test is running, is because it works a bit like monitoring. It just instruments your application. So while the application is running, it monitors what kind of code is executing. And then it doesn't matter if someone is clicking in the UI and triggering code execution that way, or if someone is calling APIs via an automated API test, or if some unit test is running in your CI pipeline. All of these cause your code to be executed, and then the profiler monitoring kicks in and records which lines are being executed. Which particular profiler tool we use for your system in particular depends on which programming languages you use, which frameworks, and what runtime environment you have, and so on. So there's a whole range of tools that we use regularly with different customers. For some languages, the most common languages, we have our own tooling, like Java and C#, for example. For less common languages, we often use open source tooling that is available that can do the same thing. In the end, all of these produce coverage files, which are usually XML or JSON files that just contain all of this information, which lines of code were executed, and then either send it to TeamScale directly, or you have to do some scripting to upload this to TeamScale. Either way, TeamScale uses these two pieces of information, what has changed and what was executed during the tests, to calculate these untested changes. Emma already also said that oftentimes we have more than one type of test. We had a question about unit tests before, but sometimes you have something like a component test or higher level tests like integration and system tests. Maybe you have some manual, some automated tests. Usually people also have different environments where they run their tests. We usually want to capture as much of this testing effort as possible and feed it all into TeamScale. So ideally, TeamScale knows about all of these types of tests. And the nice thing is TeamScale can then show you for each type of test, what is the test coverage and what are the test caps. But we can also aggregate over different types of tests. So at runtime, when you do the analysis, you can select which types of tests are you interested in at the moment, and TeamScale will give you the aggregation of these. So that you can answer questions like, where are changed methods that have not been covered in any of our test stages? Because these are obviously then completely untested. So far for the technical details. If you have any questions about how this works on a technical level, now would be a good time. Otherwise, I go into a bit of the usage scenarios. All right. Otherwise, if they come up later, just interrupt me.
There is a question in the chat. How would a manual tester know which changed code belongs to which UI screen? From the developer's point of view, it is comparatively easy.
Exactly. Thank you very much for the question. There's actually two answers to this. One answer we've already seen. I'll just jump back to the slide from Elmar. A second here. So the obvious answer is, if you as a tester don't know the code well enough to decide what this red rectangle means and where in the UI you have to click to make it green, then one easy way is to talk to the developer that made the changes to that method that caused it to become red, and then they can tell you what the kind of changes they did and how you can interact with the UI to run through that code. And TeamScale has a bunch of ways that we'll show later on in the demo, how you can get from a red rectangle to the name of a developer that knows about it. The other answer I would put back a bit, because that comes later on as one of the usage scenarios that makes it easier to get a link from test gaps to functionality in your application. I'll come back to that. Any more questions?
None so far. So I would say, please go ahead.
All right. So I have 3 usage scenarios that I'm going to show you. And the first one, I think, is one that everybody knows, which is a hotfix test. So you deployed something to production, your customer reports an important bug that you want to fix in as little time as possible to make them happy again. And there's no preparation for this, it just happens at some point. But the good thing is it's usually not a gigantic change, usually only a few methods are being changed to make the hotfix. But we have time pressure, and we want to make absolutely sure that what we're shipping to the customer does not introduce new bugs with the changes that we made for the hotfix, because some confidence by the customers probably already lost when they found an important bug. So we want to make sure that from now they have a good experience, and what we ship is rock solid. How can the test gap analysis help there? So what you see when the developer is done making the changes to your software system in the test gap analysis is something like this. So we have a large software system. In this case, this is an SAP software business information system, but doesn't really matter what kind of technology it is. You see a few methods have been changed, 8 in total for this use case here. And what the tester does in this case is what they always do. You first ignore the test gap analysis, you just do a retest of the functionality of the bug that was found. So you go through the steps that the developers use to reproduce the bug and see if it still happens or if it's gone now. And this is exactly what our customer did here. They ran through that, and then afterwards you can look in the test gap analysis. And here they got this picture where you can see that with the retest of the bug, in which they confirmed that the bug is no longer there, they only ran through 4 of the 8 changed methods. And this is interesting because usually you'd expect that if you retest it and the bug is gone and you see that the bug is gone, then you've run through all the code changes, because the developer is only supposed to change things related to the bug. Well, actually what happened here is something that is very, very common in software development, namely that the specification for the developer that the developer got, that they implemented here, did not cover all of the edge cases. So in this case, the framework that is used in this SAP system forced the developer, while they were fixing the bug, to also implement some edge cases that weren't directly related to the bug, that no one had ever thought about before, but they still had to do it. And now this is an interesting point, because now the tester can ask the developer what these edge cases were, and then together they can decide, Is this something that is business critical and where we also have to make sure we didn't introduce new bugs because the customer might run into this? Or are these edge cases completely exotic, for example, and we don't really care about them and it doesn't really matter if bugs are in there? But in this case, the customer thought that, our customer thought that maybe this could also happen in production, that people run into these edge cases. And so they did some additional tests to make sure to also cover all of the edge cases that the developer found while they were implementing this. And they ran those additional test cases, and this was the result that they got. So in this case, because so few methods were changed, it was actually achievable to get everything green here, and this gave them good confidence that they can ship this this hotfix to the customer to and make sure that there's no additional bugs in there. Now to a little bigger example. This is something that up to a few years ago we saw at pretty much every customer, where there were regular so-called release tests. Basically, the idea here is you prepare for a release, you have a lot of development activity going on, and then before you do the actual release, you have a dedicated test phase where you just want to make sure that what we were releasing is rock solid and there's no big bugs in there. Usually there's some kind of feature freeze where people aren't allowed to commit any bigger additional changes anymore to make sure that what you're testing is actually what is being shipped later on when you do the release. And the scenario that I'm going to walk you through is actually the one that Elmar already had on the slides before, the one with the big tree map that you've seen. And in this case, as you saw, this was a lot of development activity that happened there over several weeks. And to cover all of those changes, the customer Munich Re was outsourcing a lot of the testing activity to a so-called test factory, which were 5 testers in India that got a list of manual test cases that they have to run, and they ran them over 2 weeks in several different test sessions. And of course, after the first few days, a few bugs were found and the developers shipped a few bug fixes. And then the testers get a new version. So instead of 7.0.0, they now test 7.0.1, for example. And then in that case, of course, they don't start with 7.0.1 with the very first test case again, because there's not enough time to retest all of the old test cases on the new version, but rather they continue with the next test case. And this is what we call cumulative testing. So this is why they tested 6 different versions of the system in those 2 weeks. And TeamScale takes in all of that data and puts it in the right order and makes sure that the test gap analysis can also handle different versions of the system being tested. Now, the changes that the developers produced, you've already seen in the slides from Elmar. Same thing for the test coverage, just to remind you what it looked like. And then these were the test gaps that came out when we looked at this with the team shortly before the release. This was a few days before they were going to do the release. And as you can see, there's a lot of big red areas here. On the lower left here, for example, or in the top right, or in the middle here. And this is, of course, not what you want to see when you're shortly before the release, right? There's a lot of especially new functionality indicated by red here, which is about to be released, where no tester ever ran through that code. And this was very shocking for the team. This was not what they expected. What happened here? Why did the team miss so much of the new functionality? The reason in this case was that they were actually trying to automate all of the test cases for the feature tests for all of the new functionality. So they had a big test automation project where they tried to write a lot of automated tests, but unfortunately that completely failed. So not a single test case for the new functionality was finished, and the testers in India only got the regression tests, so for the old functionality. So they did everything right, but they only had like part of the picture. There was a bit of a miscommunication there. And so in the end, the new functionality basically didn't get any tests. And then in this scenario, of course, this is rather problematic because the team was pretty sure they couldn't just ship all of this code without ever having tested it. And the release date was pretty close already. So what did they do? They postponed the release, and they scheduled some additional testing to cover all of the new functionality. Unfortunately, the time was too short to write new manual specifications for the testers in India. That takes a lot of time. And it was also not realistic that any of these automated tests would be done in time for the new release date. So what did they do? They did a so-called explorative test, or some people also call this a monkey test, where they basically asked all of the people who made the requirements, so the requirements engineers and people from the business and the end users who were going to use the software in production. They told them, listen guys, you know what you ordered for this release, what kind of features you wanted. Take 2 weeks, try to cover as much of those features as possible and tell us if you find any bugs. And so 23 people walked over the system in over 2 weeks in several hundred test sessions. And again, different versions of the system because there were some bugs found and some bug fixes. And produced about the same code changes from the developers, just some minor bug fixes in addition. But wildly different coverage, as you can see. And then, of course, also different view on the test gaps. So with this explorative test, they also covered most of the new functionality now, as you can see. There's no really large red areas anymore. Most of the big red areas have gotten some amount of testing. Still, we went over that picture in detail with the team to make sure there's no big areas left where risky code changes will be shipped to production untested. And I just want to highlight 3 of these areas because those were kind of interesting back then. And we also see this happening regularly at other customers. So at the top right, the one you can see here, this was untested code for a good reason, because this was actually dead code. So this was code for a feature that should have been removed, but only the UI parts were removed, not the backend code. And so the backend code was not actually reachable in any meaningful way and could be deleted afterwards. And so it was okay that this was untested. So this is also a result that we often see when people use test gap analysis, that they stumble across code that was changed but can't actually be reached anymore and can actually be deleted afterwards. The one in the middle here, this was basically the reverse. Because the release cycles were pretty long back then, developers had some stretch of time while the tests were running where they didn't have anything to do. So here someone already implemented some code for the next release, but in a way that was also not reachable from the UI. So in this case, there's also nothing that the testers would have to do to test this, because the testing will happen next release. And you can just mentally jot down that this is something that you don't have to care about right now, but that you can look at later. Which is something, I think we had a question before about this sort of thing. This is the same thing that they did back then. And then finally, the one on the bottom here, this was actually interesting functionality where they saw a big risk if this goes to production untested, that there could be bugs in there that they'd have to hotfix. So they did extra tests here. What was this? This was export functionality for some risk data to Excel or a CSV file, I don't remember. This was unfortunately hidden behind some dropdown. So people would have to click a few times to get to this, and nobody thought about this and did this in the exploratory test. So here they scheduled an explicit test to test this critical functionality and make sure there's no obvious bugs in there. So I hope you can see a bit how the test gap analysis can highlight important problems and risks for such a dedicated test phase, such a release test. We also see the same kind of behavior sometimes from customers, not just for releases, but sometimes also for their sprints, where at the end of the sprint, there's a dedicated test phase, or someone is doing dedicated tests at the end of the sprint. They're the same things apply.
I would take the opportunity to put in a question from the chat, which I think fits here well. So now on this tree map, we have an aggregated view over different types of tests, for example, unit tests and manual tests. Mm-hmm. Now the question is, do we have the possibility to derive a prioritization from this information? So for example, if a function is not covered by unit tests, but only by manual tests, maybe I want to prioritize the function that only has manual tests to add unit tests in the future. Or I could I define quality gates on the aggregation, so certain thresholds maybe for unit tests, test gaps, and different ones for manual test gaps?
Yeah, thank you. Excellent question. So I think this is 2 parts. One is the thresholds, and the other is how can we compare and contrast different types of tests. And as I already said, team scale differentiates between the different types of tests. And at runtime, you decide which ones do you want to view. So it is very easy to put, for example, 2 different types of tests next to each other and do a comparison, and also to get lists of methods that are covered in one but not in the other, and so on. And then you can use that to prioritize, for example, where do I want to spend more effort on unit testing. Some people are also looking at maybe want to spend unit tests, especially in areas where we don't have any structured manual tests yet, to make sure that the areas where we don't have any test coverage get some additional unit test coverage and so on. So there's lots of different strategies that you can run, and TeamScale feeds you the data that you need to decide this. The second part of the question was about thresholds. That's also an excellent question, and many customers like to do this, where they define thresholds for how much coverage do I want to have in certain code areas for a certain type of test. Usually this is for automated tests, where you want to make sure that if you add new code, you don't decrease the amount of unit tests that you have, but rather you continuously improve. And TeamScale also has ways to find out the percentages of different types of tests, how much coverage do you have in certain areas, and then we also have tools to enforce certain minimum percentages, for example, in builds or in merge requests and so on. Any more questions, Sven?
So there's a question which is a little bit further off. So with a view on Java, which recommendations do we have to collect and visualize test coverage and test gaps, or tools or frameworks, preferably open source?
So I'm guessing this means which kind of coverage profiles do we recommend, right?
So I would say it has 2 parts. One is collecting coverage, which I would say is profilers. And then there's the visualization question, which is probably a separate one. Okay.
So in terms of profilers, as I already said, for technologies like Java and C# we have our own that we use. Those also are built on top of open source tools and are open source themselves, actually. So if you look on our GitHub profile for CQSE, our company, you can find those if you're interested in those, or just shoot me an email afterwards and I'll send you some links. And in terms of the visualization, I really recommend you look at what TeamScale can provide, because we have lots of different ways to interact with the data that the profilers provide. And we do a lot of additional stuff on top, for example, the test gap analysis, where we combine the raw coverage data with the code changes, which gives you additional insights that you can't get just from the coverage profiler itself. Any follow-ups or more questions?
Yeah, there's a really long question I didn't have time to read yet, so I just read it out and see where it goes.
Sure.
If I understand correctly, the test gap analysis brings testers more closer to the development team, which could help the testers even to write a targeted progression test cases with the help of developers. The first question is, would this tool be helpful if the developers have the possibility of covering the new or changed code using their unit tests before testers even jump in?
Oh yeah, a very good question. So if you have already a lot of unit tests, this is also something we sometimes see with customers. Test gap analysis is still helpful, because unit tests, as we all know, are not silver bullet. So there's a lot of different kinds of bugs that unit tests can't find, where you have to look at the integration of different components, for example. And in these cases, higher level tests that dedicated testers do provide a lot of value as well. And so what you usually want to do is, when the higher level testers are interacting with the test gap analysis and you already have a large unit test coverage, then you probably want to turn off the unit tests in these visualizations to make sure that you spend the manual testing effort or the other higher level test suite effort on parts where those tests don't reach yet. So for example, in this case, you would look into these larger red areas here and decide if maybe this is somewhere you can spend some manual test effort and use that time there, even though maybe these areas already have unit test coverage.
Okay, and then the second question that follows up on this, could we integrate such a test gap analysis into Jira, and if yes, how?
Yeah, excellent question as well. We have an integration with Jira. I'll show a bit later how that works. Basically, we can push information about the test gaps into the Jira tickets so that when you are working in Jira, you always have this information visible there as well, and can use this to prioritize, for example, on which tickets do I want to spend more effort and on which do I need to spend less effort because we already don't have many test gaps.
Okay, so that's it with questions for now. Please go ahead.
I think that was also the perfect segue to the next part, because this is really goes back to the Jira at the end. Because what I've shown you so far was one big release test, where at the end of a development life cycle, you do one big test phase. But this is actually something that we see less and less our customers doing, because as Elmar said in the beginning, the release cycles are getting shorter and shorter, which makes it much harder to reserve enough time at the end of development of a program increment or a release for the testing. And so testing has to happen sooner and earlier in the development lifecycle. And this usually means that it's much more integrated with development. And also doesn't happen only in one place anymore. Like for a dedicated release test, you probably have a release branch where all of the code that is to be released lives, and then you do the testing on that code. But if you can't do it this late, the testing, you probably have to do it on the master branch or on different feature branches and so on. And this means it's much harder for us as test managers to have a good overview of which tests already happened, on which branches and which code, which changes have been covered and which changes haven't been covered. And so this was really a challenge for us for the test gap analysis, where we had to invent a new way of looking at the data that still makes it possible for you to see what is still left untested, even if testing has happened on different versions, on different branches, and at different times throughout the whole release cycle. And what we do here, and this comes back to what we talked about with Jira before, is we take the data that you have in your issue tracker, so Jira, Azure DevOps, work items, and so on, and we break down the test gap results per ticket or per issue in your issue tracker. So in this case, you see an example here from our own issue tracker, which is Jira, where we have a bunch of tickets. Each one has its own row. And on the right, you can see the test gap information. How much of the code that the developer changed to implement this ticket has already been tested, and how much is still completely untested. I'll drill down into one of the tickets. Here you can see basically the same tree map that we saw for the entire system before, but this is much more focused. This is only the code that the developer touched while they were implementing this feature here. So you don't see the entire system anymore, but a much smaller amount of code, which is really great for me as a single tester, if I'm because I usually get assigned one ticket that somebody implemented and I have to make sure this is tested well. And so now if I run my tests as I usually do, I can look in this view afterwards and make sure that there's no important test gaps left for this feature. And the great thing here for me as a tester is this is all related clearly to some functionality, which goes back to a question we had before about how can you find out what kind of things do you have to do in the UI regarding an open rectangle. Now I already have a link to some concrete functionality requirement and so on that was implemented here. So it's much easier for me as a tester to find out what does one of those rectangles do. And even if I can't figure it out by myself, it's also very easy for me now to find out which developer do I have to talk to understand this code here, because that's just the assignee who implemented this ticket, right? So I can look up in Jira who that was, and then I can ask them. So this is again one person already in the question before said it quite well. This brings developers and testers much closer together, makes interaction much easier between them, and makes it much easier to improve our tests this way. The other great thing is for me as a test manager, even if tests are happening on 17 different branches, I don't have to care anymore because I can break it down by requirement. And no matter where the requirement was implemented or tested, TeamScale always tells me how well are we standing with tests for that requirement. And we actually have a lot of functionality to filter all of the requirements and issues that you have in your issue tracker to just the ones that are really important to you. For example, critical issues or issues implemented in the current sprint or issues implemented for the current release and so on. Of course, to be able to give you this view, we now don't just need information from the version control system and from your test environments, but also from your issue tracker, namely which issues do you have, what is their name, who was the assignee, and so on. So we have an additional connector that imports all of this from your issue tracker, and we support a whole bunch. Again, if you don't find yours on our website, just contact us. We also have ways to import data from trackers that are not directly supported. But basically, for most people, this just means you configure an account here in TeamScale, and then TeamScale pulls all the data that it needs from the issue tracker. And then we need one more thing to be able to calculate this issue coverage. Namely, we need to know which code changes belong to which issue in your issue tracker. And the way we get this is there's actually two ways. One is from the commit messages. So when a developer checks something in, a lot of people already write the number of the requirement that they're implementing or the issue that they're implementing in the commit message. So for example, here you see it in the style that we do it in with CR hash and then a number. Doesn't really matter what the format is, as long as the number is in there, TeamScale can read it and can map it to the issue from the issue tracker. It works the same way if you don't write it in the message, but rather put it in the branch name, which is also that we see people doing more and more. Then TeamScale can read it from the branch name and also associate all the changes on that branch with that issue. And then together with the test coverage that we have for these code changes, we can calculate these issue test caps for you. Sven, any questions about this?
No, there's currently no questions. Now there's a question. Since we're a little short on time, I would say we continue with the demo and answer the questions afterwards, because probably many of the things are already answered in the demo already.
All right. Then that concludes my part, and I'll hand over to Jakob for the demo.
Yes, very good. Can you see my screen?
Yes.
Yes.
Yes, great. So welcome everyone, also from my side. My name is Jacob, and I personally use TeamScale every day together with customers, and many of those use TeamScale to perform the test gap analysis. So I have the pleasure today to show you most of the things my colleagues already presented on the slides in a live demonstration. And since we are performing test gap analysis, I need some system under test. And for today, I brought Pixelitor, which is an open source drawing application implemented in Java. And its functionality reaches somewhere between Microsoft Paint and Photoshop. And our story today, or my story today, is that someone from the development team just most recently finished the implementation of a ticket of an issue, and I'm in charge of validating whether the changes implemented in the ticket are thoroughly tested. So since we are doing that in TeamScale, I will just leave the PowerPoint presentation and focus on my browser. And I've already opened up the login page of TeamScale or the TeamScale UI. TeamScale itself is a Java server application, so it usually runs not on the local machine, but in my case, it's here in the local machine. That's why it states localhost in the address bar. And as so often, we will start logging in, and we are directed to the dashboard perspective. So on the left-hand side, you see different perspectives in TeamScale, and each perspective offers a different viewing angle on the quality metrics TeamScale calculates. So today we don't have the time to look at all of them, but we will focus on the dashboard's perspective, go to the test gaps perspective later on, and we'll have a short look at the activity perspective right now because it offers a good start. So what you can see here is something like an extended log of your version control system. So you see who did the last changes, you see the commit messages, you see the committer here, it was Elmar, you see how many files were changed, you see some alerts and findings that stem from static code analysis TeamScale also performs. Since Elmar is pretty keen on mentioning the ticket ID or the ticket number prefixed with a number sign in the commit message, TeamScale can infer a connection between that commit and the issue it is belonging to. So here, this commit belongs to the issue number 1. You are not only seeing code commits here, but if you do some tests on your software system, you can also upload the test coverage, and afterwards upload the test coverage to TeamScale, and afterwards you will see also that coverage upload appearing here. Back to the dashboard's perspective. So if we create a new dashboard, you can freely configure it. So add arbitrary widgets from the right side to the dashboard. For now and today, we focus on the test gap tree map widget, which offers exactly the view Elmar already showed on the slides. And yeah, it represents the results of the test gap analysis. Each widget can be configured, and we have the dialog here where we can enter on which path in the software system we want to apply the test gap analysis. The analysis needs some period of time where it should be applied to, so a start date, the baseline, and the end date until when changes and coverage should be respected. And as already said in the presentation, we can select different coverage sources. So for example, right here, only unit test coverage was uploaded, but later on we would also see other sources here. For today, I prepared 3 different dashboards, and each dashboard contains exactly 1 tree map. We have the changes tree map at first. Afterwards, we will have a short look at the execution tree map and the test gap tree map. Let's start with the changes one. So you all already have seen such a picture on the slide, but you can easily see that it is much more interactive right now. So if I hover over the methods here or the nodes here, you can see that if I hover on this node, you see the method name in the middle, you see in which file it is implemented, and also some state, which represents the state of the test gap analysis. This method is gray, meaning it was not changed since the baseline. A tree map is always representing some tree structure. The tree structure here is the file and folder structure, and also that means that files that are in the same folder are displayed next to each other. Methods in the same file are also located next to each other. So we also remember that there are colors. The yellow color means that a method existed at the baseline at the start date of the analysis and was altered or modified afterwards. And the red ones mean the method was newly introduced to the software system. If we change to the execution tree map here, the semantics of the colors change a bit. So the gray methods, or in this method, we just visualized the execution coverage from the tests. Gray methods are not executed in the tests, and since we green methods are executed in the test, since we only uploaded 1 single unit test coverage to TeamScale, there are only 3 methods executed right now, but we can roughly remember the location, which comes in very handy for us. So there are 2 methods on the lower left-hand side that are covered by the tests, and 1 method, a larger one on the right-hand side, that is also executed by that single unit test. For the test gap analysis, we are interested in the combination of both the tree maps, the changes tree map and the execution tree map, and we take the changes tree map at the bottom and lay the execution tree map over it. So we will just do that. I will shortly change back to the changes tree map. A lot of red and orange again. And if I now change to the test cap streamer, we see that two methods that were all earlier yellow are now appearing in green. That are exactly the two methods that were executed in the unit test. If we look to the right-hand side, we see that big, larger method is appearing gray here because this one was not modified since the start date of the analysis, and it's running in production as is, so it's not of relevance for that analysis. We are often getting asked how to reach actual code from this perspective. That is pretty easy. So if we click on a single method and then on open method, we are directed to the so-called method history. We see the evolution of the method in the software system. So it was added sometime, it was changed several times, last time by Emma, and you can also see that it was covered by a test. If you would further click on name, we are landing in the code. Back to the dashboards, back to the test cap tree map. So I remember my job for today. I should just verify that a change or the changes of a ticket are thoroughly tested. So on this big test cap tree map, I see way too many methods, and it's hard for me to guess which method belongs to the ticket I should validate the test. That is why we want to switch to another view, the issue test caps view. Since TeamScale, as Fabi said, is not only connected to the version control system, but also to the issue tracker, we can see several issues here. Right now, all the open issues, but we could also define some other queries that show me issues that are assigned to me or belong to the current iteration or such. For today, our issue of interest is issue number 1 with the title Improve the Gaussian Blur Filter. Clicking on the title leads us to the issue details view, and that lists several information from the issue tracker again, the title, the issue number, the current state, it's open, who created the ticket, this was Dennis, who it is assigned to be implemented by, and also some very, very brief description. The Gaussian blur filter could be improved. It is not really Gaussian enough. And some sections down below. And we will see which sections there are. Let's start with the commits one. Since Elmar mentions the ticket ID in each commit message, TeamScale can infer which commits belong to the issue. So there are 2 commits. Having that commits allows us to calculate which files were changed. Those are 2 in this case. We have several findings from the static analysis, but for today, it is most important to have that test gap section here. And what we now see is a much smaller tree map that only shows me the changed methods within the context of the issue. It counts only 4 methods, 1, 2, 3, and 4. And what I'd like to see is that 2 methods are green by now, meaning they have already been executed in a test, but 2 methods are yellow, which means they have not been tested after its latest modification. And for me, as responsible, I can now decide, do I want to release this feature right now? Do I want to merge this feature? Or do I have to go in a retest? And since I know that the Gaussian blur filter is very important to all the people that use Pixelitor, I decide to go into a retest or a test, and I will do that in the UI of Pixelitor directly. Therefore, I need a running instance of Pixelitor. I will start that on my command line, just with the command run, and Pixelitor starts up. To test the Gaussian blur filter, I need some picture I can apply the filter to. Let's try to draw the TeamScale logo here. Very difficult. And I think the Gaussian blur filter is here. And let's try it out. It should be blurred. Yeah, that seems to be fine. I've tested this filter a lot and know how this works. Let's say this seems to be great. In my test management tool, I draw a big green check mark. This test passed, all settled fine. We can close Pixelitor again. And now something happens that I didn't told you. So with the run command here, I did not only start Pixelitor, but also attached a coverage profiler to that run, meaning that every method that was executed during my test session was recorded, and it was also afterwards directly uploaded to TeamScale. We know that we can see coverage uploads in the activity perspective. Let's just open that up. And we see, I've opened up the activity view in a new tab, that there's a manual test coverage upload just from roughly 1 minute ago. If we click on that, we can also see which methods have been executed during that run. The coverage should also have an effect on that little test gap trim up here. And I just reload the page to make it visible. We now see that large method here on the left-hand side was earlier yellow and is now appearing in green, and I've reached it in my test session. But there's still one method that appears yellow here, meaning we have not reached it in our test session. Let's see if we can see what I have to do to reach that. I see the method is located in the motion blur op Java file. It is the motion blur operator filter, and I think I'm not sure why this was altered as well. Let's look at the history. So there's some other refactoring. It might be that the developer thought it would be good to extract common functionality to a utility function or such. And now I'm left with one test gap and I have to decide what I should do. I think I have also to retest the motion blur filter, because also this is very important to work for the users of Pixelitor. We know what to do. We will just go in another UI test session. Create again a canvas, this time an easier picture, and apply the motion blur filter this time. I've also tested this filter a lot of times, and now some in-motion unsharpness should appear, but nothing happens. So what I've now discovered is a bug, and I have to admit we have done this on purpose. So this bug is in there, and I have to cross the test result or mark the test result with a large red X in my test management tool. This test failed. We have to fix that bug. Nevertheless, this test is finished for now. We close Pixelitor again. You already know test coverage was profiled in the background and uploaded to TeamScale. What effect has this on the test gap trim up here for that single issue? Let's reload the page. So the test gap is now closed. Now we have a completely green test gap trim up, but this, as Elmer said, does not mean that there is no bug in that, but only that all the methods that were changed during the ticket are executed in the test. We know that we wouldn't have found that bug in the motion blur filter if we wouldn't have executed the motion blur filter, and we wouldn't have executed the motion blur filter if we wouldn't have used test gap analysis, because in the ticket description, there's nowhere written that also the motion blur filter was modified. So now I create a bug ticket or fix the bug directly. In this sense, it's pretty easy for the demonstration, because I have also a script with me that just applies the fix. There's not much magic applied here. We just move one commit further in the repository and are done with the fix. Should be always so easy. I again reload the page and see the effects on the issue details view. We see the method on the down right side is now yellow again, meaning it was again edited, modified, And we also see that now not 2, but 3 commits are associated with the ticket where the motion blur filter was fixed. Now I could go into a retest again, but I promise that this time the motion blur filter would also work. All the test sessions also had an effect on the overall system test gap tree map. As you can see here, from the many yellow and red methods, also a large amount got green by now. What we have seen now is how we can apply issue test gap analysis to a single issue. And we have also found a bug with during applying the test gap analysis for an application implemented in Java. If you are not using Java, but any of the orange programming languages listed here, we have test gap analysis already running and set up at some place. But also if you are more on the exotic side of programming languages, do not hesitate to just ask us whether we can make it possible to run test gap analysis also in your environment. So I didn't see the chat during my demonstration, so maybe, I'm not sure, do we have time for questions at this point, Emma, or should we?
Yes, we do.
Yeah, great. Do we have questions?
I think not yet, but please, if you have questions, put them into chat.
So there's actually one question that we delayed from earlier, which is, I think, quite fundamental. So in the test gap analysis, is it also possible to see the front end and the back end at the same time, in case they're, for example, not written in the same technology?
Yes, this is possible. You can aggregate different programming languages in TeamScale when you would have, for example, 2 parts in the tree map. On the left-hand side, some, for example, JavaScript files, and on the right-hand side, the Java part of an application, and upload test coverage from different test runs. So yes, that is definitely possible.
Okay, thank you. There is also one raised hand again.
Concerning your live demo, perhaps switch back one sheet. I would like to another one. I would, and
should I go here?
For example, yes.
Yeah.
It's a live demo, and on the top of the sheet you have mentioned January 1st of 2016 till now. And there's so much code which is not tested but is new. What does this mean? Do you just roll back for your live demo, or how can I interpret this information?
So in fact, it's just a demonstration, and also the demonstration repository contains only changes until, so we can scroll back here until maybe 2016 or 18, I think 2018, and not further. So for a real system, we wouldn't have that baseline so much way back. Does that clear things up?
Yes. In the beginning, you showed the configuration of TeamScale, and I think there was a possibility to make a time range. Perhaps it's baseline and end date. So you can fix or inspect special time distances with your application, yeah?
Correct.
Okay.
So you can, with the baseline, which is effectively the start date of the analysis, you can say from which point in time should TeamScale collect the changes. So if I would move that baseline further to the more present time, less method would test methods would appear as changed. And with the end date, I could specify how long do I want to consider changes or also coverage.
Jakob, I have to step in because we are nearing the end of our time box. Let me just wrap up for those that have a sharp deadline afterwards. Yes. So thanks a lot for everybody who took part. We were interested in your feedback. What can we improve when we do the workshop for the next time? Maybe Sven can post the link for the workshop in the chat. The second thing I want to mention is for those of you who speak German, next month we have another talk together with a customer, SEW Eurodrive, and we will present about several years of experiences we collected together in introducing quality analysis tools and processes into their development process. We have some more time to fill out the feedback thing. I had to skip the cost-benefit analysis we did with Munich Re. I'm sorry for that, but we will send it around afterwards. We have an article on that, and we can send it to you afterwards in case you're still interested in that. Thanks a lot for participating. And for those of you who still have time and questions, I will stick around a bit more to answer the questions. And then Fabian, Jakob, and I will go into the breakout rooms in case one of you wants to do a one-on-one chat. Thanks a lot. Sven, I think there was one more question in chat, which we didn't answer.
Yes, there's one more question. Is there a reporting system or summary via PDF or so per release, which could be shared to the stakeholders to give them confidence that we have tested most parts of the release?
Yes, good question. There is. We have different ways of doing reporting, and that's a very important artifact to make it more impactful for the different stakeholders. If you're more interested in details, please reach out to us afterwards, then we can provide more information on that. Thanks for the nice words in chat.
Yes, thank you all for participating. There's lots of thank you following up. So far, no further questions. So we also have the email addresses and even the phone numbers on the slide here. So please feel free to reach out. We will also send around the slides at the latest on Friday, Central European time. We'll send the slides and also the recording, so you will have time to look back at the session, the workshop from today, and reach out if you have any further questions. Yeah, I see also some messages that unfortunately people have to leave. Maybe if they're in the same time zone as us, there's just evening calling, right?
Yeah.
At some time you have to stop working.
Then let's open the breakout rooms.